Okay, I'm going to go over a square root review for your test. Okay, so we're going to start with the problem 9 plus square root of 2 divided by 4 minus square root of 7. Okay, how we divide is we need to rationalize the denominator. I'm not allowed to keep any roots under, I am not allowed to keep any radicals in the denominator. So I'm going to multiply by what's called the conjugate. So conjugate means we're going to change the sign. So I'm going to multiply both sides by 4 plus root 7. Okay, and I can FOIL these out. Okay, so I'm going to FOIL these out, first, outer, inner, last. So I like to draw a box to FOIL out. So I'm going to come down here and draw my first box. I have 9 root 2. I have 4 root 7. So I'm going to multiply. 9 times 4 is 36. 4 times square root of 2 is 4 root 2. 9 times root 7 is 9 root 7. Root 7 times root 2 is root 14. So if we combine, we have 36 plus 4 root 2 plus 9 root 7 plus root 14. So that goes over here on top. 36 plus 4 root 2 plus 9 root 7 plus root 14. So let's come down here to the bottom and let's do the same thing. So we got 4 and negative root 7. We have 4 and a positive root 7. So if we multiply 4 times 4 is 16. We have negative 4 root 7. We have positive 4 root 7. And we have negative 7. So we have 16. Notice our middle terms are going to cancel. Okay, we have positive 4 root 7 and a negative 4 root 7 minus 7, so this cancels. So 16 minus 7 is 9. So we have 9 on the bottom. So that's our answer. Notice I can't simplify anything. Root 2, root 7 I can't add, so we're done. Let's try another one. What if I have the problem 1 over 1 plus square root 3? So again, I'm not allowed to keep a radical in the denominator, so I need to do what's called rationalize. So I'm going to multiply the top and the bottom by the complex conjugate. So instead of 1 plus root 3, I'm going to do 1 minus root 3. And so I'm going to FOIL these out. Well, the first one I don't really need a FOIL, all right, because I just have a 1 minus root 3. And if I draw a box for the bottom, I have 1 root 3, 1 negative root 3. 1 times 1 is 1. Root 3 times 1 is root 3. 1 times negative root 3 is negative root 3. And negative root 3 times negative root 3 is negative 3. So if I write it out, 1, notice my middle terms are going to cancel. So I'm just left with 1 minus 3, which is negative 2. So I put negative 2 down here on the bottom. And I can't simplify much except maybe the negatives. I can pull that out in the front. So do a negative 1. And if I pull out a negative in the front, that's going to make this a positive. Over 2. I'm done. Again, if you're having trouble on these, you can use Desmos and get this as a decimal. You could put it in Desmos and see what or a graphing calculator and see what decimal answer it is, and then see what decimal answer the final answer is. So that's another way to check your answer if needed. Okay, let's try another one. What if we have the fourth root of 6 divided by the cube root of 2? So again, we need to rationalize the denominator. So I'm going to multiply top and bottom by cube root of 2. Well, 4 times 3, we can multiply those roots. 4 times 3 is 12. 6 times 2 is 12. And then cube root of 2 times cube root of 2 is 2. Okay, let's try another one. What if we have root 30 times root 10? Well, a root times a root, we can keep the same root and multiply the numbers underneath. So we're going to do 30 times 10. Well, what is 30 times 10? 30 times 10 is 300. Well, what is a perfect square that I can multiply to get 300? That would be 100 times 3. The square root of 100 is 10 on the outside. So that can get booted outside and 3 stays on the inside. So let's try another one. What if I have a cube root of 16x to the 7th times cube root of 12x to the 9th? I'm going to try to simplify these two first. So I'm going to try to simplify individually. So first off, I can say that 16 I can rewrite as 8 times 2. And anytime you have an exponent that is larger than the outside, I can make it smaller. So x to the 7th is bigger than 3. So let's rewrite this as x to the 6th times x. Let's do the same thing on this side. We'll cube root for 12. Well, that's just 6 and 2. Neither one of those is a cube root, nor is 4 or 3. So let's just keep that at 12 for now. We have x to the 9 cube, which we could simplify easily by taking x, and we're taking 9 and dividing it by 3. So if we simplify, cube root of 8 is 2, so that gets booted outside. The 2 stays inside. The 6, x to the 6th, I can divide by 3. So 6 divided by 3 is 2. And x to the 1st here, I can keep underneath. Well, on this side, 9 divided by 3 is 3, so I have x cubed. And again, cube root of 12 just stays underneath. So still not done, so let's multiply what's on the outside. I have 2 times 3 plus 2 on the outside is 5. And then cube root would be 12 times 2x, which would be 24x. But I'm still not done because 24 I can rewrite as 8 times 3. And ding, 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 cube root of 8 is 2. So that gets booted outside. So the 3 and the x stay on the inside. And lastly, 2 times 2 is 4. So we have 4x to the 5th, cube root 3x. So lots of steps with that one. Lots of steps with that one. Again, if you're having trouble solve this, you can pick a number for x, easy number for x, 1, 2, see what decimal answer you get, and then double check utilizing that same number for your answer choices. That's one way you can utilize a graphing calculator or Desmos online graphing calculator to find solutions. Let's take a look at another one. What if we have 2 square root 18 plus 3 square root 2 plus big square root 162? So how do we simplify this one? Well, let's start with 18. 18 I can break apart as big square root 9 times 2 plus 3 square root 2 so square root 162 we can rewrite as 81 times 2 so square root of 9 is 3. That can get booted outside. 2 stays underneath the radical. Square root of 81 is 9. That gets booted outside. This 2 stays under the radical. So 2 times 3 is 6. So how many total root 2's do we have? We have 6 plus 3 plus 9. So 6 plus 3 is 9, plus 9 is 18 root 2.